Hi everyone. This week's lab is going to have you write assembly code using jumps and branches. And since we haven't covered that real thoroughly in lecture yet, I thought I'd record a quick video to help you get started. So what you did last week in assembly was just string together a big long list of arithmetic or logic instructions. But as you know from writing Java code or C code, you don't always just run all the lines of code in order. Occasionally you need to move around a bit. So we call this moving around flow control, and there's two main types of instructions for flow control in assembly: conditional and unconditional branches. So in MIPS, we call an unconditional branch a jump. You're just saying, go to this line of code. So here I have in front of me 9 pretty boring instructions, and let's say after the 4th instruction, we want to jump down to the end. So there's two things we need. The first thing we need is a label. And a label is just like a variable. You can call it whatever you want. You just put some unique text string there followed by a colon. And now, if I want to unconditionally jump from where the cursor is now down to that label, I just use the jump instruction, the J. So now if I save this, compile it, and step through it, you can see that we go through the first 4 instructions. When we get to that jump instruction, it jumps down to where that label is. Now, more often, what you're doing is a conditional branch that lines up with an if statement. So let's say I want to do something along the lines of if t0 is equal to 7, then I'll do that jump. The instruction for doing that is BEQ. It stands for branch if equal. Now the trick with BEQ is it can only compare registers. So if I want to compare t0 to 7, I have to put that 7 in some sort of temporary register. So I can do something like this. AT stands for assembler temporary, so I'll put 7 in there. And so if t0 is equal to the assembler temporary, then I'll do a jump here. So we can save that, compile it, and we can step through one line at a time. Now notice that t0 is not equal to 7, so it's just going to continue running those next lines of code. There's also an instruction, branch if not equal, that will jump if t0 is not equal to 7. So you have those two at your disposal. Okay, so to practice, let's convert this little snippet of Java code into assembly. And through this, just so your answer lines up with mine, how about if we put x in t0, y in t1, and z in t2. Notice these are all comments right here. Okay, and then I'll pause for a second and type out this code. Hang on. Okay, so pause the video and write that section of Java code in assembly. All right, so what do we need to do? Well, the first thing is to check for equality. We need that constant 7 in a variable, so I will put that in T3. That's my first register that's unused. And then I can do a branch if equals. I want to see if T0 and T3 are equal. And that's the label I'll use. So if they are equal, oops, these should be indented. Not a requirement, just makes the code a little easier to read. So if they are equal, we want T1 to equal to 14. Now, where does the code go if they're not equal? Well, notice if they are equal, we come down here. If they aren't equal, we're just going to run the next line of code. So we can put that right here. And now, when both of those are done, we want z to equal 15. So what's wrong with this right here? Notice that if x is equal to 7, it'll work just fine. It'll check, it'll say, oh yeah, x is equal to 7, it'll jump down here, set y to 14, set z to 15, and move on with the rest of the program. But if x is not equal to 7, it will come down here, set y to 21, and then set y to 14. Well, that's not what we want. We need to make sure we skip over this part if we're not running it, and that's what a jump is for. So I'll just call this end if, just to give it a name. And then, so when I'm done with the else clause, I can jump to the end if. Now you might notice something here. This is a little bit backwards, right? The else clause came before the if clause. And that's just the way assembly works. Because if you think about it, you're saying if something is true, go somewhere else. Whereas when you're writing code in C or Java, when your if statement is true, what you run next is right there under the if. So it is a little bit backwards. Now this could be backwards in one of two ways. So here, it's backwards in that we've switched the else and the if conditions. But another approach would be to just swap the direction of the conditional. Another way to do the same thing is instead of saying branch if equal, branch if not equal to not equal. And then we could put the if clause where we normally see it and the else clause where we normally see it. And then just that if statement ends up feeling a little bit backwards. So whichever way you prefer to write it is fine with me. The key is just being able to think through it and get the assembly code organized in a way that works. Okay, now what if instead of saying x is equal to 7, I wanted to say x is less than 7? Well, there aren't any hardware instructions that do a less than. We'll see why in a week or so. So think back to the projects. What instruction do you have to do a less than? Well, you have SLT for set less than. And in this case, we're going to compare it to an immediate, to a literal 7, so we'll use SLTI. And again, we'll need a temporary register of some kind, so I can use T3. So this will set T3 to 1 if T0 is less than 7 and 0 otherwise. So then, in principle, I could do something like this. But that's not quite right, because remember, we want to compare two registers. So here's a shortcut. If we're looking for a 1, and the value is either 1 or 0, we could just do it the other way and look to see that it's not equal to 0. So this would work for less than. Again, with the else and the if places swapped. And so if you don't like swapping the else and the if places, we could just turn that branch around. And so instead of saying if branch if not equal, we could just change that back to a branch if equal and go down to not equal. Okay, so there you have just a couple of quick examples of using jump, branch, and using branch with set less than. And remember, if you have a branch, it's going to feel a little backwards, either in where you put the code or how you write the condition. Also remember that the branch statements only compare registers. So if you want to compare it to a literal value, place it in a register. I will quickly note that the assembler will let you cheat a little bit. Notice if I do something like this, branch if equal T06, and then I hit the assemble, oops, and then I hit the assemble, it will assemble it, but it automatically turned my 1 instruction into 2. So that's just a little shortcut that Mars provides, and I would encourage you not to use that for the first couple of assignments, just so that you get a firm feel for how the hardware actually works. Okay, so hopefully this helps you get started on lab, and if you have any questions, be sure to let me know. We can talk as an entire class, or I can jump into a breakout group, whichever works better for your particular situation. Have fun.